Thank you very much. That was quite an introduction. Let's see, how much time do we have?
You have as much time as planned. So 25 minutes.
Yeah, let's see what we can do.
Yeah.
So yeah, we have the first slide already up there. Querying the minds, or how AI agents learned to program the edge. We'll take it from top to bottom. We have built a platform actually that enables interactive analytics of streaming data in distributed systems. And my colleague Magnus, we will tell you more about this, but what we are really looking for here is another mine. And we're going to explain why in a few minutes. There are no clouds 700 meters underground. We're looking at machines here at work in a mine in Boliden. These heavy-duty machines, they do generate rich data streams, such as battery health, energy regeneration, driving patterns, vibrations, all that kind of stuff that is lovely to analyze and get an improved understanding of. On the other hand, there is no convenience of the cloud or the desktop down here. The bandwidth that is there must be prioritized for other kind of stuff. And these heavyweight data streams would be rather expensive to store in cloud anyways. So it's kind of awkward to get a hold of these data streams in a nice fashion. So we made a platform that hopefully makes all this a bit less awkward. Over to Magnus.
Yes. Erik has touched a bit on this briefly, but let's elaborate a bit on why the cloud-first AI falls short in these cases. I mean, the traditional way for doing edge AI is just to stream data from the edge up to the cloud. You do the processing in the cloud, and then you send commands back down to the edge. And at best, there's some sort of static pipeline on the edge that sort of transforms the data before getting streamed up to the cloud. But the sort of the development runtime on that pipeline is usually too large to have any meaningful impact. And in the mines, as we mentioned, the connectivity is not really good, and it's intermittent at best, and the latency really kills any real-time decisions. I mean, we're talking minutes of latency here, and bandwidth is very expensive. But this is not just a mining problem. This is a reality for a lot of situations, like all the industries where the infrastructure is distributed and the connectivity is intermittent, like if you have fleets of devices or in a factory or offshore rig or whatever. And yeah, the sort of uncomfortable truth of edge AI is that most solutions really require a big fat pipe up to the cloud to actually work. And well, there's a lot of big players in the AI field, and why haven't they solved this? I mean, it's obvious that we need a solution here, and but they are also usually cloud providers. They want to sell cloud services, they want to sell cloud storage, and they're not interested in limiting the need for cloud usage. So, yeah. So here's where our platform comes in, SA Engine. It's got a really small footprint. All it needs is a C99 compiler, so it can run on basically anything from microcontrollers to servers. And it embeds a combined main memory database and computation engine directly on the device. And our extended SQL language, it lets you define functions like stream processing pipelines, machine learning models, and analytical queries that they get optimized and JIT compiled into native machine code directly on the device. So you have native performance as well. And it comes with an abundance of built-in analytical functions like statistics, like fast Fourier transforms, principal component analysis, a lot of signal processing and ML algorithms. So this means that each truck, in this case, becomes a programmable compute node, and not only a database. It becomes more like a database on wheels with extra everything. And the fleet also becomes sort of a distributed system that you can query with this SQL language. So you can manage the fleet through the same platform, and you can interact with it using this sort of extended query language. And yeah, Erik can mention what we have done with this as well.
Yeah, we have actually done some stuff here. So we were teaming up with Volvo Group and Boliden. That's where the mine came in, Halmstad University and RISE, in a project called Freeport. We deployed our software on vehicles that were connecting to our services, and using that we could monitor things like battery health, energy regeneration, driving behavior. And we were doing that where it happened, when it happened, thanks to our agent that was running in the telematics unit of the truck. So we had access to all the data that was continuously generated. We have put some work in decoupling the analytics cycle from the software lifecycle, and that gave us two nice things. First of all, the observability. So with the software, your vehicle fleet will turn into a distributed database, like you mentioned, available for interactive querying, obviously when the connectivity is there. So if the connectivity is not there, you'll just have to wait until the query gets through, and then you'll get a response. So that could take, typically in a setting like this, anything from a couple of seconds up to half a minute. So the experience is not that bad, at least. Okay, and the other nice thing is the model lifecycle management, the way it should work. So deploy and update analytical models is done without touching the firmware, without touching the OS or any other software. So you will have no downtime and basically no turnaround time when switching from one AI model to the next one. Because the first AI model you will deploy on your truck will not be the perfect one. I can promise you that. I will actually bet my life in that. Another thing I want to tell you that we learned is that we didn't know when the project started that it is very difficult for a mine owner to get data from the machines. On the other hand, we figured that our runtime is actually geared for exactly this kind of use case as well, since we allow our users to specify where the result streams should go. It's just another one-liner in a function call, really. So once Volvo and Boliden agreed how to share data between each other, our platform could go in and do that kind of work as well. And whenever they had a change of heart, they could also change the data sharing within seconds or minutes. And we do love these kinds of projects because that's what's shaping our platform. So thank you very much, Volvo, Boliden, Halmstad, and RISE. So let's also look at our platform and have a look at some details. And this is the short harbor tour. So if you want more technical detail, you can visit us at our booth. But long story short, our software is installed on edge devices shown at the bottom, typically on resource-constrained telematics units. They do contact our backend services shown in the middle, running either on-prem or in cloud. So if you have a large fleet, you'll have a large number of instances of the bottom connecting to our backend services. Then users will interact from the top using a Visual Studio Code plugin or a web page, or even use an agent using either our REST interface or our CLI for interacting with the platform. Using the studio, then they can query these devices interactively, develop models, and also do the lifecycle management of all these models. That's what we call DevOps activities, I guess. Another nice thing is the interoperability with AI models written in external environments. So let's say you have a nice trained model that you made in TensorFlow or something like that. Then your problem is that there is no TensorFlow. There is not even a Python runtime in any of these machines in the mine. So how to easily transfer this model use our platform is my answer, at least. So thanks to the ONNX importer on the top left in the picture, we can basically take any ONNX model which gets further optimized and lifecycle managed, just like any other queries and functions that goes along with it. So we have actually seen a couple of cases when we managed to optimize a YOLO model that was into something like 20% faster than the standard TensorFlow execution backend on the Raspberry Pi CPU, which is at least a bit exciting, I think. So I have more details here. This is basically what's inside the runtime on each edge. So just to go over it quickly, because I love this, we have the low-code queries and models coming in on the top. Each query gets rewritten and optimized using standard. This is standard database technology. You can call it AI without the hallucinations, if you like. So this is rule-based rewritings. And then on top of this, we also have this just-in-time binary compiler. So any query that the user is posing in a declarative fashion will be optimized and then immediately translated onto machine code for the target hardware. Currently, we support x86, ARM-A, ARM-M, and RISC-V. We can talk more about that offline. Then we have, any query or any query plan will then touch on data sources, extensions, sinks, and any of these internal modules in a kernel, depending on the work it should be doing. So one question is, of course, what were we doing? Well, it was not our job to write any models. That was the job of Halmstad, Boliden, and Volvo, and they did a good job, but I think that's going to be a sort of separate breakout presentation in the interest of time here. But suffice it to say that, yes, they did random forest, for instance, for predicting energy consumption of auxiliary units, such as cab heater, battery heater, what have you. And these random forests, they were successfully running on a device that was not really made for running random forests. So I think this is rather exciting. And we also had a bonus exercise on rolling resistance. I don't think we have time for that today, but please visit us in our booth if you want to look at some physics of a real truck. So we have to move on, and at the closure of the project, we had the project leader saying exactly this. We have heard a lot of promising AI presentation, but this is the first time we see something that actually works for real in our trucks. So I think that's that's a nice sales pitch, actually, when I come to think of it. So in a sense, we were providing this complete infrastructure that goes beyond prototyping. And the project partners were actually using this to deliver insights from real trucks. I think that was all pretty exciting. So that's sort of good news from last year. But Magnus, you are leaning into the future, aren't you?
Yes, I am, and that's what this conference is all about, I guess. I mean, the Freeport project was good, but that was a year ago. And as you all who are very involved in AI know, that a year in AI, that's basically ancient history. The Freeport project, it was validated, it was proven, it was shipped, and the project leaders, they were blown away by our amazing technology, of course. And but we were not really satisfied. Now we have a lot of development going forward in AI, and we have agents, we have autonomous reasoning, we have tool use, and so we looked at what we built, and we realized that we have a platform that makes physical assets programmable through a query language, and now there are AI agents that learn how to use tools. So the question became, what happens when an AI agent learns how to program an edge device using our platform? And I think it's important to sort of dig down into the distinction here between sort of existing technologies and our platform. And I guess the first question is this just another API? And no, it's not. Like in most agentic edge AI solutions, you have some sort of static pipeline on the edge device, and you're streaming data up to the cloud through maybe like a REST API or an MQTT broker or a Kafka stream or something, and then you provide that data to the agent. So the agent gets the data, and that's it. And our solution is fundamentally different. I mean, the agent doesn't query a pre-made pipeline. The agent writes the pipeline. So the agent writes the SQL code that gets compiled into machine code and runs on the edge device. So the agent shapes what's actually being processed at the source. So it creates new computations, like new aggregations and new analytical functions, and deploys them to the device in real time through the platform. It's like the difference between reading a dashboard and being able to program that dashboard from the ground up, but the programming is running on the actual edge device. And yeah, keep it a bit more on the previous slide.
Okay.
Yeah. So, and also, since each sensor on the edge device is modeled, the agent can also reason about the availability of the data on the edge device, which is kind of important. So, yes, Erik.
Now it's my turn.
Yes.
And I just saw the 5-minute mark as well. So I'm going to speed it up here and relate this slide to what we just saw and to what Anders Innerman just said this morning. He mentioned the cognitive companion. And that's how I like to think about this. We have the human user and we have the agent. Together they are forming the data pipeline all the way to the distant edge device by interactively querying it, because that we know also that users and agents alike, they work best when there is short turnaround time in going from question to answer. So I'm claiming that we are doing exactly this here, the cognitive companion kind of stuff, which is exciting, I guess. And as we said, yeah, we have we are doing these experiments in mines, for instance, to keep shaping the product. So what we really want from you is another mine, so we can keep experimenting. And this is one example of an experiment, I guess.
Yeah, this slide shows is sort of mentioning the potential of this. I guess you can already sort of, through your knowledge of AI agents, you can probably comprehend the potential when it gets to be able to easily program edge devices and doing it in a very fast-paced sort of feedback manner. And so just imagine how you can examine doing sort of diagnostics on different stuff, comparing it to others in fleets of devices. Like, it will program its own pipelines in order to get the information it needs to compare it, and then give you a synthesized result that explains what the ground reasons is for whatever you're asking for. So yeah, and this just shows some minor experiments that we have done. We're not fully there yet, but we're on good way, and I would say that if you ask us again in a month or two, we might even have this.
But what we really want is another mine.
Yes.
So that we can keep running experiments on real vehicles, on real data. And we're not too snobbish about particularly mines. We can do with heavy-duty vehicles as well. That's totally fine. Or heavyweight machinery, or shop floors. So come talk to us if you have any of those. With that, I think we have like 10 seconds left for questions.
Thank you so much. Give them a warm applause.
Okay.
And we do have a couple of minutes for questions, if that's fine. And thank you once again so much for a super interesting talk. And to begin with, could you maybe tell us a little bit more about the actual process about transforming these trucks into this kind of data collection fleet? And yeah, how is that process looking like? And connected to that, what kind of hardware do you put into these trucks? Is it like custom hardware, or is it just more like general purpose?
Nice question. I take the second one because that's
Sure.
that's the easier one to begin with, and I need sort of a warm up. Typically we live off whatever is there, and typically in a heavy duty truck there is at least one telematics unit which is comparable to a lightweight version of a Raspberry Pi. So you'll get an ARM A with limited amount of memory, maybe one to two cores, less than a gigahertz, something like that.
Right, cool. Thank you so much. And in terms of sensor sets for the data collection and stuff, that comes ready with the trucks, or is that also something that you install?
That comes with the trucks typically, so we live off whatever we can get from the CAN bus, for instance, and in a heavy duty setting there is usually more than one CAN bus, and that's also something that we usually work out together with a partner. So whatever data will be made available for us and so on, that varies between use cases. Additional sensors include positioning, obviously, and vibration, such as accelerometers. And there was another interesting question. I don't want to skip that. So that was what does it look like to roll this out on? On
exactly. How do you actually prepare this machinery, these trucks for this process?
So the infrastructure that needs to be in place is obviously we need to put our backend services somewhere, and that's something we work out together with a partner. If they prefer to run it on premises, on their premises, that's totally fine. And then we'll have to set up some arrangements in order to agree basically on the operations of that and all that. And then on the fleet side, we need obviously to get our runtime running on the telematics units. So that's another sort of setup activity that comes with this. But once that's done, then and that would be sort of the software lifecycle management of the project, right? But then once that is done, then the analytics lifecycle management will sort of commence, and that's when you sort of can have this interaction with your fleet of vehicles.
Wonderful. Thank you so much. And with that said, we want to thank you so much for the presentation. Okay. And here we give you a gift. It's an umbrella, perfect for the Gothenburg climate. And
that's
give them a
useful.
warm applause.
Thank you.
Thank you so much.
Thank you.